A lesson on 2.8 covers absolute value functions, and these are some of my favorite functions, not just because I'm a math teacher and I like them, but because I actually find them to be the easiest type of functions to graph. So first of all, I want you to get your calculator, and I want you to figure out how to find the absolute value function on your calculator. So let me minimize this, and everybody go to y equals. Clear out whatever was in the last problem, and we're going to find the absolute value bars in a strange place, but the same place we found the integer function. Go to math, and then you go over to number, and the very first one is called ABS. That is the absolute value function. So if I wanted to graph the absolute value of x, that's exactly how I would do it. And then if you have a weird window from some of the last problems we've done, hit zoom 6, and you're going to see what the absolute value graph looks like. So you should notice he looks like a V. He has what we call a vertex in the middle, 2 branches on the side, and he's got a lot of symmetry. So bear with me while I try to transfer this to my graph. I want you to do the same thing. He has a vertex, oops, right there at 0, 0, and he seems to kind of, oh geez, go up. Okay, so hopefully yours looks a lot better than mine, but these are straight branches on the side. Basically what happened is it took a linear graph, y equals x, and it took this negative branch and he flipped them up to the positive quadrant. So let's look at the next couple problems. I'm going to go to my calculator and I'm going to graph both of these. Let's pull up the calculator. So first, I want you to graph the absolute value of x minus 2. Now make sure the subtract 2 is inside, whoops, the parentheses. And let's look at the graph. So it seems to be shifted right 2 units. So that's what I'm going to write down on my paper. This was shifted right 2 units. So the vertex, instead of being at 0, 0, was now at 2, 0. And I'm just going to kind of sketch in a graph here. I don't need anything really pretty. So let's try the next guy, which is at x plus 3. So go back to y equals and change this to say plus 3. And now this graph seems to be shifted left 3 units, and that's exactly what happened. So instead of being at 0, 0, he was now shifted at negative 3, 0. Still had his 2 branches going like this. Okay, the next problem, absolute value of x and then a plus 2 on the outside. So make sure when you go to y equals, you close the parenthesis after the x, and then the plus 2 goes on the outside. So this time the graph seems to be shifted not right or left, but up 2 units. So my vertex is now at 0, 2. Still has the 2 branches going off to the side like that. So take a wild guess what do you think is going to happen with absolute value of x minus 4. If you guessed down 4, you were exactly correct. If you don't believe me, go ahead and graph it. Okay, the next problem, negative, and then the absolute value of x. So let's go to y equals and type negative, absolute value of x. Now you've probably noticed that your calculator does an overtype typing method. So sometimes it's easier just to clear it out and type it in again, but that's up to you. So this time what seems to have happened is it takes the graph and it reflects it upside down over the x-axis. So it hasn't been shifted right, left, up, or down, but it's been reflected. Oops. Again, hopefully your graph looks a lot better than mine. And then let's try 3 times the absolute value of x. So go back to y equals. I'm going to change this to a 3 out in front. And then it's a slight difference, but hopefully you notice this seems to be a skinnier graph. And what has actually happened is these branches, instead of being a slope of 1, now they're a slope of 3. So I'm kind of do my best to fudge that branch. Ugh, that's terrible. Try again. Okay, that's not much better, but you get the idea. So I know we all love to use our calculators, and calculators are great. However, These are a lot quicker if you do them without your calculator, because I'm going to ask you a lot of questions about them. So the first thing I'm going to ask you to do is look at the general function, whoops, which is, let me grab that, y, or f of x, equals a times the absolute value of x minus h plus k. So the first thing I want you to make a note of is the vertex. The general position for the vertex in this general form is at the point h comma k. So you're going to notice the h is inside the bars and the k is outside the bars. You're also going to notice that there's a negative symbol built into the formula for the h. So whenever you think about the h, you always got to think about opposites. So if it said x minus 3, the h is really a positive 3 because the minus is part of the formula. Now the slope of the branch is going to be the a, the number out in front of the bars. So if you don't see anything out in front of the bars, there's an invisible 1 there. So let's look at number 7. Where is the vertex? Well, there's nothing inside the bars and there's nothing after the bars, so my vertex is actually at 0, 0. And the slope of the branch is the number that's out in front, 2. So to graph these, you just draw your vertex at 0, 0. And then for the slope of the branch, since his slope is 2, you're going to travel up 2, right 1, because that's the slope of 2. But because it's symmetrical, you also are going to go up 2 and left 1. And then once you have those, 3 points graphed, oh geez, hopefully you do a much better job graphing than I did. Try again, Abruzzo. Oh geez. Alright, well, you get the idea. So number 8, the vertex this time. Remember, inside the bars you got to think opposite, so that's really a positive 3, and there's nothing off to the side, so positive 3, 0. And since there's no number in front of the bars, there's an invisible 1 there. So at 3, 0, you've got your vertex, and then your slope is 1, so we're going to travel up 1, right 1, and we're also going to travel up 1, left 1. So you've got a slope of 1, slope of negative 1, and there's your absolute value graph. Well, that was much better. Good for me. Moving on. The vertex for number 9. There's nothing by the x, so that's a 0, and then there's a 4 off to the side, and the slope this time of our branch is a 1/2. So at 0, 4, there's your vertex, and your slope is up 1, right 2, and we're also going to travel up 1, left 2. Okay, number 10. The vertex, remember, you got to think opposites for the x's. So it's really a negative 2, comma 1, and the slope is the invisible 1 out in front. So negative 2, 1 is right there, and your slope is up 1, right 1, and up 1, left 1. Oops, missed it. Alright, again, hopefully your graphs are looking a lot better than mine. Number 11. Your vertex is at, remember, opposite of the x's, so positive 4, comma negative 2, and the slope of your branch is going to be a 3. So at 4, negative 2, there's your vertex, and your slope is up 3, right 1. 1, 2, 3, right 1. And then up 3, left 1. So there's always a beautiful symmetry, whoa, to these graphs. If you can graph, apparently I cannot. The next problem, the vertex, remember, think opposite, it's at negative 5, comma 3, and the slope is a negative 1 out in front. So negative 5, 3, be right here. Now for your slope of negative 1, that means we're going to travel down 1, right 1, but we're also going to travel down 1, left 1 to keep it symmetrical. So you're going to notice this absolute value graph has been flipped or reflected upside down, which is what we knew happened when you threw a negative in front of it. Okay, number 13. The vertex is at negative 1, negative 6, and the slope of our branch is 1/4. So negative 1, negative 6 is right there, and then slope is up 1, right 4. And then we're also going to travel up 1, left 4. Oy. Do a better job than me. Alright, thank you. The vertex for the next problem is at negative 3, comma 7, and the slope is a negative 2/3. So vertex of negative 3, 7 would be right here. Now be careful, your slope is a negative 2/3. You're going to travel down 2, right 3, and then down 2 and left 3. Oh goodness, terrible. All right, moving on. This time I'm going to give you a graph, and I would like you to find the equation. So it would probably be helpful if we identify a few things. Let's start with our vertex. The vertex of this graph is at the point 2, 1. And then let's figure out our slope. So if I travel from here to here, and I count, it went down 1, 2, right 3. So it looks like my slope is a negative 2/3. So let's put this all together. Y equals, my slope was a negative 2/3. And then remember, inside the absolute value bars, it's always x minus the x-coordinate. So the x-coordinate of my vertex was a 2, and then plus the y-coordinate, or the k. So our answer is y equals negative 2/3, absolute value, x minus 2, plus 1. And then the last example, I think if we identify our vertex first, that'll be a good start. Our vertex is at 2, negative 2. And then to figure out our slope, I'm going to use the right branch always. It looks like we travel up 2, right 1. So it looks like our A is a 2. So putting that all together, 2 goes in front. Absolute value of x minus the x-coordinate. And then normally I'd say plus the y value, but plus a negative 2 would be kind of weird, so I'm just going to say minus 2. And you could always verify these by graphing what you think the equation is on your calculator and making sure it matches. But I'm pretty darn sure we did that right. That concludes the lesson on 2.8.